Welcome everybody to today's presentation about our new software that we just released called AERMOD Wizard. This presentation will show you the software itself and will be mostly a hands-on demonstration of what the software can do. So we won't have too many slides today, but we'll show you the software itself. So in today's demo, we'll show our new product called AERMOD Wizard, which, while it does not directly run air dispersion models like AERMOD and ScreenSeer CalPuff, it helps you obtain the metadata that is needed to run those models, and it also helps you to obtain monitoring data that can be used to calculate background data values used in air dispersion models such as AERMOD. So today I'll be going over the AERMOD Wizard software from Providence and showing you some of the features of that software. If you have questions during the presentation, please ask them in the chat window, which I'll be checking periodically. All right, so the features of the software are going to be displayed on the next slide, and we'll just go ahead and go over them one by one. So the first one is that we can display sources and met stations and monitoring data stations on a map of the United States. And in our software, I've gone ahead and opened our test file, which is an example modeling file that's included in the software, which has just one source of emissions. It's a pretty simple example. And our source is located in the state of North Carolina. So we can actually take a look at the source here. And also at the top of the software, or sorry, on the menu bar, there's an entry here to edit the source. So the software allows us to enter the source locations for all of our modeling sources, as well as the emission rates, but it's not for all pollutants, it's just for a limited set of pollutants. And you can enter multiple sources here just as you can in our other programs like these, and also copy and paste the source data from Excel. And then in this example, we have just one source in North Carolina, USA. Now on the left side of the screen is where we can display other data, not just the sources. So here we can actually select what to display. We can display class 1 areas and display their boundaries and their receptors. We can also display surface and upper air stations, which I will do now. And for each station that you do display, you can select that station. You can select that station so as to go ahead and work with that station and obtain metadata for it, or monitoring data as the case may be. And if I go and move the mouse over the station and right-click, there's a menu of options here, options that can be taken, which I'll demonstrate later. But also, whenever I move over a metadata station, it tells me if I've already downloaded the data for it, and if I haven't, how many data observations are available at that station for each year and each month. In this case, it looks like, for example, for the year 2013, for this Asheville, North Carolina station, we have plenty of pieces of data available. If now the station is, let's say, 0, that would mean that it doesn't have data for the period, for the time period in which you're interested. Then, in addition to displaying metadata stations, this tool also allows you to display monitors for 6 criteria pollutants, which are NO2CO, ozone, PM2.5, PM10, and SO2. And for example, let's go ahead and select the SO2 stations. All stations surrounding our source are going to be displayed. And I can also move my mouse over it and see what are the periods of time for which data are available for the station. For example, this station has data only starting in 2017. So if I'm interested in modeling something in 2012, for example, I wouldn't select this station, I would select another one. Notice that this station is Haywood County Station. Has much more data available. Is available all the way, actually, 1994 to 2007. So I can just take a look at the stations and select which ones I want to use for downloading data. Now, if I select the different ones such as NO2 or ozone, we can also select the station by clicking on it, and that will allow us to download the monitoring data for that station. I'll demonstrate this a little bit later in today's presentation. And actually, that's next item on the list, is downloading metadata and monitoring data files. Let's go back to our surface station, and I want to download the metadata for the year 2013. To do that, what I would do is I would left-click on the station to select it, and when that happens, a blue circle appears around the selected station. Then just go to the menu and say Met and download surface data. And I want to select the hourly data file for the station. From there, I would simply select the year in which I'm interested, which is the year 2013, and tell it to download this file. I believe this goes out to the US EPA website or server to get the data. And it looks like actually this download has been successful. And let's see. Sorry about that, there's a temporary technical problem there. So now that's successful, I can just click the close button and say, okay, say close to close the form. Okay, now that I've done that, now if we look at the station again, if we move the mouse to the station again, now we'll see that the 2013 data have been downloaded as well. Let's go into do the same thing for an SO2 monitoring station. Now to actually see the stations, I have to click the monitors checkbox here and select the monitors from my source. And we have, if I zoom in a little bit, we have a monitor that has data available 2017. And next we have one that has, cool. Oh, no, that's the service station. Actually, let's go into monitors. Monitors. But there's a monitor near our source. And as we can see, we have already downloaded the data for 2011, 2012 ports. Let's go and download the data for 2013 now. And to that, I'll go to the monitors menu and say download monitoring data. And again, select the year 2013 and click download here as well. It looks like that was successful. Now we have monitoring data. Again, this isn't used directly on an air dispersion model, but we can use this monitoring data to as an in-running such model. For example, to get the background data value for a year. Now, once we have downloaded this surface data, we're going to display it in a Windows within our tool, and that's actually fairly simple to do. All I need to here is move the mouse over the station, and again we can see the data files that we have already downloaded. Right-click on it and select the Windows option and say which year they want to display. And I'm going to go ahead and select the year 2013. And when that's done, AERMOD Wizard will go ahead and open our Windows application, which is also included in the software, and display our Windows for the year 2013. And similarly, if I select a different year, such as 2011, it will also export that value to our Windows program and display the Windows for that year, which this is now the year 2011. And as you can see, this AERMOD Wizard makes the process very simple. All we need to do is just right-click on the Surface Data Station and tell it to create the windows, and it will do it for you. Now the next feature I'm going to talk about is calculating the percentage of missing data. This is actually talking about the monitoring data. So let's say we just downloaded some ozone monitoring data for this monitoring site, but there are actually requirements about how complete that data must be to be useful to us, which I believe is that it must have 75% of data must be present in every year. We actually have a tutorial on this topic called the PG Technical Details, and our program also includes several other tutorials on how to use the software, including downloading this kind of monitoring data and working with it. So we go to the Technical Details tutorial. which is one of the tutorials included in the software. It does say that you usually need to talk to a reviewing agency or a regulatory agency about what kind of files they will accept, and but in general, for ozone, which we're talking about now, no, but in general, you must have at least 75% complete data for background data. So let's take a look and see if our data file meets that criteria for 75% completeness. And to find that out is, again, really simple with the AERMOD Wizard program. I would right-click on the monitoring site and say Summarize Monitoring Data. And now it's new from if you're in it, now we'll just go ahead and select the year 2013, so we should just download the file, and then just go to Annual. And it looks like this was actually a very good year. We don't have data. We don't have data for all the year. We only have, it looks like, from April 1st to October 31st for ozone. But we have very little data missing, only about 5%. And I can actually go quarter by quarter and see what that percentage is. Now, I think for the first quarter, we just have no data. Second quarter, 5% missing. Third quarter, also just about 5% missing data. That's a very good. That's a very good. That's a very good year to use if you're going to use this year for background data, or even for just ozone background. If I do the same thing and select in a different year, such as the year 2011, we will see the same thing that our AERMOD Wizard will summarize data for you and tell you, how many hours do we have that have any data, and out of those, how many hours that have data in the files and that are missing. And then I can also go quarter by quarter and see. Right, so the first quarter has no data at all. It's 100% missing. The second quarter is very good. This is now for the year 2011. Third quarter is good, about 5% missing. For the fourth quarter, though, we have 69% missing. And the AERMOD Wizard will warn you in that case that we have less than 75 hours that do have data. So this 2011 file, we might not want to use that one. We might not want to use that file for our background data. We might want to use the 2013 instead. But again, AERMOD Wizard just calculates and displays these percentages for you really easily. Now, if you need to calculate background values for aerial models such as AERMOD, AERMOD Wizard will allow you to do that as well. If I right-click on the station, if I right-click on the station and tell it to process monitoring data, now for ozone, it's actually going to allow us to fill missing data for ozone and write a background data file. But for another pollutant such as CO, For another pollutant such as NO2, if we have a monitoring station, we can do this again, just basically I would right click, say process monitoring data, select my years, and then AERMOD Wizard will calculate the background values for that station. Now on this first one, I can just review my data and see how much of that is 75% or more complete. So for the year 2011, for NO2, we have slightly less than that complete. It's just about 70%. For 2012, we actually have a couple of quarters with missing data, a lot of missing data. In 2013 is almost all data. Now we do calculate the background values and select, for example, we select the option to calculate background values by month. Use the first high value. AERMOD Wizard will go ahead and calculate that for us, and in the end, it will present us with the background values in a format that both the software can use and just AERMOD can use in general. If you're doing monthly background data, as you said, it takes just a few clicks to find the monthly background values. Now they can be used, and now what I can also do is tell AERMOD Wizard to write the AERMOD file with that data. And when I do, this file can easily be copied and pasted into an AERMOD input file, or you can just reference from an air dispersion modeling software. Now, for this example, like NO2, but AERMOD Wizard actually includes several tutorials on downloading and processing monitoring data for 4 of the criteria pollutants: NO2, ozone, PM2.5, and SO2, which discuss this in more detail and discuss obtaining the background data values for these 4 pollutants. Now in example with NO2, we obtained a background data table that has the background factors for each month. If you select monitors for other pollutants, again, such as ozone or CO or PM, this will work very similarly. What you have to do is right-click on the station, which is your monitoring site, and just tell it to process monitoring data, and we'll calculate those background values for you. And finally, what I want to show today is actually just showing a forward trajectory within AERMOD Wizard. Let me go and just reload our test file. And what we can do is, if we have our surface data downloaded, we can actually see in which direction the wind. We can see in which direction the wind blows for a small period of time, and we can see that if something is emitted from our emission source, where would those pollutants travel in a limited period of time? Now to that, I'll select my station and say forward trajectory setup. I'm going to do this for the year 2013. Let's do this for one day, which is April 1st. So I select April 1st, hour 1, to April 2nd, hour 0, and this was giving all the data. Sorry, this will say the trajectory for that one day in April 1st, 2013. I'm also going to start the source. When I say display trajectory, and zoom out a little bit, we see that the wind was blowing mostly from the north to the south that day. The search here is hour 1 goes to hour 2, 3, 4, hour 7, and so on. It looks like the wind was blowing in the southerly direction that day. What we can also do is right click on the station again, and tell it to display that project in and to animate it, basically. Looks like that went by pretty good, but if you have a larger period of data, you can go and display that hour by hour, so to see where on an hourly basis does the wind blow. Which also means that if your source started emitting balloons at this location at this time, then the emissions are likely to travel in this direction for this April 1st, which I'm displaying. This feature can actually be used to see what happened during an emissions event. For example, if we know that something happened on that April 1st, we look for trajectory. See where is it likely that the emissions spread from starting at a certain hour and going for the next few hours. So to summarize, AERMOD Wizard is a tool for downloading and processing metadata and monitoring site data, and using the data to assist you with air dispersion modeling. It doesn't run the air dispersion model directly, but assists you with getting the data that you would need to from those models. It also has some additional features such as the forward trajectory that can help you with perhaps modeling, not directly modeling specific mission events, but maybe visualizing what happens during those specific mission events. Thank you for joining our presentation today, and we will now go ahead and take questions from the audience.